We will discuss complete concept on stationary points with the help of two examination style questions. At stationary points, you can have local maximum minimum or point of inflection. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss about stationary points with the help of some test examples. You see two questions here. Both of them have come in previous test papers. We'll answer these questions. Also, we'll understand the concept of stationary points. And in further videos, we'll take up more complex questions based on this concept, which will help us in curve sketching. So the major topic in this part of calculus is curve sketching, where stationary points play a major role. Question number 1. The quadratic function f of x equals to ax squared plus bx plus c has a stationary point. At what value of x will f of x have a stationary point? Discuss the condition when the stationary point is a minimum or a maximum. So that's a communication question for you. And question number 2 is, the graph of the function f of x equals to x cubed plus ax squared plus b has a minimum at the point 4 minus 11. Find the value of b. You can actually extend this question and also find the other stationary point, right? So that could be an extension to this. We'll first begin with the concepts of stationary point and then get into details of answering question number 1. But for the concepts of stationary point, I'll consider the general equation of a cubic function. Well, in case you want to learn from me, you can always send an email on the address given. Most of my students are performing very well. Some are right there on the top of their class getting awards and scholarships, just as Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let us try to understand what are stationary points. So our focus now will be first on understanding the concept, right? So a stationary point means something which is not moving, right? So it comes from the concept of, let me sketch a graph of a cubic function. So let's say the graph of a cubic function is like this. Correct. So if you treat movement of an object, then when it turns, it is kind of stationary at the turning point, right? So that's the corollary. So at the turning point, you see what is the gradient or slope of the tangent line. Well, at this point, if you are given the function f of x, in that case, at these points, the gradient is actually equal to 0, right? Here also, we have the gradient as equal to 0. So these points are the ones where the gradient is 0. And these are the points which are called stationary points. Perfect. Now you can see that stationary points can have a maximum or a minimum value. So as far as function is concerned, we have a maximum here and a minimum here. Perfect. Also, I'd like you to note one thing, that we have said that stationary points are the ones where the derivative is equal to 0, correct? So that is the definition of stationary points. Consider another function. Let me sketch one for you. With the example given, you might think that at stationary point, we always have maximum or minimum. My question to you is that true? Well, that is not always true. Let us consider a case, right? For example, this time I'm giving you a function which is kind of like this. Now, what do you notice? You notice that the derivative is 0 at this point, correct? Here also, the derivative is equal to 0. However, this is neither maximum nor a minimum. Do you understand? So we could have stationary points which may not result into local maximum or minimum values. Right? We also call them local maximum minimum. You get the idea. So once again, stationary points are the points where first derivative is equal to 0, right? So there could be maximum or minimum. And this type of point, which we just shown you, is called point of inflection. Let me write it on the other side. We'll discuss point of inflection more when we take up second derivatives, but this is just to give you an idea. At this point, the concavity changes. Do you see that? It is concave down, then up. So that is decided by the second derivative. So we'll discuss that later. But for sure, some stationary points will have maximum value or a minimum value as shown here. Correct? Now, the concept is clear. Let's begin with the solution of these questions. The very first one is a quadratic function ax squared plus bx plus c. And this quadratic function has a turning point, right? Every parabola, which represents the graph of a quadratic function, will have a turning point, right? And therefore, it has a stationary point. So, to discuss the concept, a quadratic function could be kind of like this, right? Or it could be kind of like this. Now, basically, it really depends on the value of a, right? So in this case, the value of a is greater than 0. And in this case, the value of a is less than 0. So you know from concepts, correct? So that is to say that we could actually find the nature later. However, it is very clear that there is definitely a stationary point at these turning points, correct? So what do we notice here? That at these turning points, the derivative is equal to 0, correct? So here also the derivative is equal to 0. So the idea is write down the function which is given to us is as ax squared plus bx plus c and find its derivative. So derivative will be 2ax plus b, right? To find the location of this stationary point, you need to equate that to 0. Is that clear to you? And then find the value of x. So we get what? So we get 2ax plus b equals to 0 means that 2ax equals to minus b. And we come to a very important conclusion that x is equals to minus b by 2a, correct? So definitely, we have found the value of x which is minus b by 2a. So that is what we wanted to do. At what point, at what value of x, so value of x, will f of x have a stationary point? So at minus b by 2a, it is going to have this stationary point. Is that clear to you? Right? You know from past that this is also axis of symmetry, right? So just let me sketch this axis of symmetry for the parabola. And this always is at x equals to minus b by 2a, right? Now, with this concept of calculus, I hope it becomes absolutely clear to you that there is a turning point at minus b by 2a. Perfect. Now, let's take up part B of this particular question, which is discuss the condition when the stationary point is a minimum or a maximum, right? So basically what we did was that we found that for the function f of x equals to ax square plus bx plus c, the derivative which was equal to 2ax plus b, and when we equate to 0, we found that the value of x was minus b by 2a. Now, to discuss whether it is minimum or maximum, what should you do? Well, you have to make interval table, right? So we'll analyze derivative using sign chart. So in this case, what we have is that the point is at minus b by 2a, right? So let's make a chart where we will analyze what happens on either side of x equals to minus b by 2a. So the critical number, which is a stationary point here, is minus b by 2a. You need to take a value which is less than this and which is more than that. So the best value to take is minus b by 2a minus 1, right? So it becomes less than. Now here I can take minus b by 2a plus 1. You get the idea. Here we can take a value like this and test the function, correct? Now, what is our function? Our function is 2ax plus b. Now, whenever you do the testing using the sign chart, it's a good idea to factor and then write. So let me rewrite the function in the factored form. So that is the key for you to understand how do we analyze it. So I could take 2a common, and when I take 2a common, I get x plus b by 2. You get the idea? See how I have rewritten this equation. So 2a plus b, right? So I took 2a common. So when I take 2a common from this, factor it out, then b has to be divided by 2a, correct? And clearly from here you can see that is why it is a 0, right? So if I put x as minus b by 2a, I do get a 0. So this factored form is very essential to do the interval test, correct? So the derivative, we'll write here, the two factors being, one is x plus b by 2a, right? And the other being 2a. So these are the two factors to be tested. Is that part clear to you? Now, since we have minus b by 2a will make it 0, and that minus will make it minus, and this plus 1 will make it positive. So that is clear for this. However, the problem here is with 2a. What is a? So a could be positive or a could be negative. You get the idea. So a could be positive or negative. So that is why we have two conditions here, right? So if a is greater than 0, means positive, right? If a is greater than 0, in that case, we always have a positive value here, right? Because this is not dependent on interval x, it is a constant. So in that case, what happens to the function when you multiply? So in this portion, it is negative, right? When you multiply them. And two positives make it positive. So that is what happens to the derivative of this particular function. So negative means that the function will be decreasing, and then positive means that the function will be increasing. So basically, if a is greater than 0, then we'll have a function which is decreasing first because it is negative in the interval from minus infinity to minus b by 2a, and after that it is going to increase. And that results into what? That results into a minimum value. So we get a minimum. Do you see that? So we have come to a conclusion that if a is greater than 0, then it means that at x equals to minus b by 2a, we have minimum value. Is that correct? Perfect. Now, I would like you to check the value when a is negative. Make the same interval chart and check it. Right? So how will it be done? Let's do it once again. So we know that the function here is ax squared plus bx plus c. The derivative of this particular function is 2ax plus b, which can be factored. We can write 2ax plus b by 2a, correct? So we know the critical point is at minus b by 2a. So we're going to analyze this situation, correct, once again. And this time, we'll take the value of a as less than 0, correct? So in that case, we have minus b by 2a as a critical point, stationary point. So on two sides, we'll take minus b by 2a minus 1, and then we'll have minus b by 2a plus 1. And what are we testing for? We're testing for the factors, and the factors are 1, x plus b by 2a, the other one being 2a, right? Now clearly, the term which is x plus b by 2a, it will be negative here and positive there. But 2a, a being less than 0, a being less than 0 will be negative always, right? And therefore, the derivative will be positive here and negative on the other side. So therefore, function f of x will be increasing and then decreasing, correct? So what do we have? This time we have maximum, right? So if a is less than 0, then f of x has maximum at x equals to minus b by 2. You get the idea? So that is how we are going to conclude in this particular case. Perfect. So this concept is absolutely clear, right? So we have answered this question, and it does correlate with what we had thought initially, right? So if a is less than 0, we have minimum. If a is greater than 0, we have minimum. And if we have a less than 0, we have a maximum. Makes sense, right? So that is how we do it. Now let's look into the second question, which is the graph of f of x equals to x cubed plus ax squared plus b has a minimum at this point. Find the value of p. So in this case, what you notice is that there are two unknowns, a and p. So we have to find two values in fact, right? So we have the function which is x cubed plus ax squared plus b. To get two equations, we also know that the point is on the function, right? So what is the value at 4? Value at 4 will be, when you plug in 4 here, we get 4 cubed plus a times 4 squared plus b. And this value, you know, is minus 11. That is given to you. So we have to use the point on the curve to get our first equation. I can always rearrange this particular value. 4 cubed is 64 plus 4 squared is 16a plus b equals to minus 11. Or we can write an equation as 16a plus b equals to minus 11 minus 64. And that gives me 16a plus b as minus 75, correct? So we have one of our equations, which is 16a plus b is equal to minus 75 after putting this value of 4, right? So that gives you one equation. Let's call this as our equation number 1. Now, second equation we are going to get using the derivative. So what is the derivative of this function? The derivative of the function is 3x squared plus 2ax. And since we have a minimum value at this particular point, so it is a stationary point, right? So we know this is a stationary point. And that really means that the derivative is equal to 0. So we know that the derivative of this function at 4 should be equal to 0. So if I substitute 4 here, I get 3 times 4 squared plus 2a times 4, correct? So we have 0 equals to 4 squared 16, 16 times 3, 48, plus 8a, right? We could actually divide by 8. So we get the value of a. So a is equals to minus 48 by 8, correct? So we get the value of a as equal to 48 by 8. So a is equals to minus 6, correct? So we found one value, which is the value of a. And now we can substitute this value a of minus 6 in our equation here, which is 16a plus b equals to minus 75, right? And then we can find the value of b. So let's move on. 16a plus b is minus 75. And we know that the value of a is minus 6, correct? Correct? So let's check. 16a plus b is minus 75, a is minus 6, right? So when I substitute minus 6 here, then what happens? 16 times minus 6 plus b is equals to minus 75, right? So b is equals to minus 75 plus 16 times 6, right? It becomes positive when it goes here, right? So we can calculate the value of b as minus 75 plus 6 times 6, 36, gives you 96. So the value of b comes out to be 96 minus 75, which is 21. Clear? So we get 21. So we have found both the values. B is 21, a is minus 6. So we have a function basically, right? So we have answered the question. Now let me rewrite the function with the values of a and b. So it is x cubed minus 6x squared plus 21. So that becomes the cubic function for you, right? Now, here is the extension. We are going to extend this particular problem for you to solve. So we have x cubed minus 6x squared plus 21. Let me rewrite the equation. The function here is x cubed minus x cubed minus 6x squared plus 21, correct? So we just figured out that the graph of this function, which is kind of like this, right? And it's given to us that there is a minimum value. And this minimum value is at 4 minus 11, correct? But we can see that there is also a maximum value, correct? At p and q, right? There is a maximum value also. So now the question for you is, Find the coordinates of local maximum on the graph of f of x. Make sense? So that becomes your question as an extended question for this particular problem. So I hope with this you understand the basic concepts of what stationary points are, how do they relate to the turning points, local maximum and minimum, and you also understood that every stationary point will not result into a local maximum or minimum, because there could be conditions where the graph could be, as I was saying, we could have a graph like this. You see that? So in this particular graph, there is a point where we do not have a local maximum minimum. However, the derivative is 0, right? So these 3 points, we have the derivative, which is equal to 0, and all the 3 are stationary points, correct? So we have a local maximum, local minimum, and we have a point of inflection, right? So we normally write this as inflection point. And this is local minimum. And that is local maximum. Is that clear to you? So with that, we'll end this particular video. I hope you find it interesting and useful. In case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.